So today we are here to see a project developed in Turbo C++ in 12th grade. I call it CBasic compiler. It's loosely based on QBasic, so it supports all the commands that QBasic supports. This for next is supported to any number of nested for loops, one under the other. And some new commands are also there, like input arrow. You can grab the arrow input, get the middle X and Y positions, etc. All these commands work as expected. So the project itself consists of two parts, the compiler and the text editor. Text editor is based on a two-dimensional queue so that I can provide the user with a free-to-edit interface, like you can go to the previous line and edit whatever you have written. The text editor gives you 5 options. Open, save, and exit are pretty much what they say. The run and compile modes are executed by the same function inside the compiler, that is, I call it execute function. Execute function knows whether the code is compiling or running. If it's compiling, then it will output errors into a file which can be displayed later into the text editor. And if it's in the output mode, it just displays the output. The compiler supports including of different files. What I do is I create a three-dimensional array with each page of it consisting of all the other included QBasic programs, and then I copy back into the main program. The execute function, the execution of the program or even the compile works by the following. It loads the source, includes files, records all the functions in a class. Then I explicitly call the main function of QBasic. Main begins executing. If it encounters any commands, it goes to the C++ implementation and goes back. If it encounters a function call, it searches for the function in the function table, records the function arguments, and then calls the function. This recursive calling of functions helps me to implement recursion, and the function calling stack is essentially maintained by Turbo C++, and the variable stack is maintained by me. How does the return statement work? Well, it works with the void pointer. It stores the actual location of the variable being returned and returns it with a reference telling whether it is safe to use this value or not. This is how I create variables. I have a template class, and I typecast the location of itself into a void pointer so that I can create an array of this. This is how I maintain scope of variables. I have an object of symbol table for each function, and the symbol table itself contains a pointer to an array of variables list. This array is implemented, pointer is implemented as a stack. So even if this function calls itself, a new variables list is pushed on to the stack, so that entry, whenever you access entry, you'll always be accessing the latest set of variables. So let's quickly see a demo of it. I'll be showing you a program that demonstrates the use of demonstrates the use of include statement and recursion. So one thing I could think of right now is a factorial thing. So I'll open the factorial program. It's 15. So see, as you can see, mat.txt is included. So let's see if I use an undefined variable and compile. It'll tell me that I'm using an undefined variable. It has all sorts of error reporting, but I can only show you one in 5 minutes. So no, it does not find any errors. So to get the actual feel of whatever we are doing, let's switch on the debug mode. Now the compiler will tell us whatever it is up to at any moment of time. We'll have to open the file again, 15.txt, and we'll run it because we know it's free of errors. So immediately we can see that a number of functions are accessing the source file, and now the function table is recording all the functions it saw. Now the main was called, and number of function arguments were recorded. Function arguments are the variables that are declared in the main function. A symbol table was created for main function. S and I variables were entered. Now it's asking me for input. Enter the number to find the factorial of. Now it called factorial, calling factorial. Now it's maybe it is main at index 0 or POW at index 1. It's searching the symbol table. As soon as it found factorial function at index 2, it began executing it. Now symbol table is created at a new location, recorded all the variables. You can see that boolean string to evaluate, then boolean bash recorded. Everything is how I evaluate the if then else statements. Now as soon as factorial 2 called factorial 1 recursively, we can see a new function table was created for the same object of the function factorial. So now when we'll be addressing the function symbol table, it will always be the latest one or the topmost one. Now, as soon as we are over with the processing, it got popped. The factorial 1 was popped first, and after that factorial 2. Now it will return to main, pop from factorial, C plus, as we can see, C++ printing from main. 2 factorial is equal to, well, 2. Now the symbol table of main itself got popped, and press any key to continue. I'll quickly show you the graphics. I've loaded everything and I've switched off the debug mode, so it should display the graphics as they are. The graphics are in program 18.txt. It's error free, and this is the code. Oh, the scroll bar works too. I forgot to mention. It evaluates all this if functions and operations, etc. Let's see. Run. So this is a program written in QBasic, which is compiled by my compiler and is running on top of C++. As we can see, it detects the collision with the edges and works pretty well. Thank you for watching. I hope you enjoyed it. All the source code along with the help file and instructions to set up is available on my GitHub repository. If you liked it, there are many more projects I've done over the years which are available on my website. I'll give it a link down below. Once again, thank you for watching.